So I am, wait, hold on. I can do computer screen. What? Because before I cannot do I actually asked Xiang to come fix my computer for me. Wait, where's my thing? Is this Chrome? No. I need a Chrome. All right, there you go. All right, so now I'm gonna do it with TI-84C here. I'm gonna sign in. Let me know if I got a different answer than you. So I'm gonna start second plus 712 because I want to reset my calculator. I don't want to deal with other things. I'm gonna graph e to the x, so second e to the x here, right? And then cosine of x. And I'm gonna make sure my calculates in radian. I think I did it wrong, so I'm gonna go back and change that. So that's not what it was. So e to the x, and then I'm gonna do cosine of x. Now, do I have to use t? No, don't use t. T is the time. Now, also knowing this is the initial conditions. Initial condition only used for certain things. So I'm gonna highlight this, and I'm gonna say that's initial condition. And we only use under certain situations. So at t equal to 1, it's a particle speeding up or slowing down. So what I'm going to do is I'm going to go back to the here. I need to compare acceleration and velocity. So I'm going to take another derivative. Is that okay? So I'm going to click on the math, and I'm going to click on 8. And for Melissa, it's going to be on the back is going to be vars function y1 and then x. So for you be x comma x. You know how to do that, right? And I'm going to do second. I'm going to do table. So at 1, so how are you supposed to write down AP exam? You're supposed to write down V of 1 is equal to 1.46. Now, how many decimal places are AP exam? 3 decimal places. Keep it 3 decimal places. Write down 3 decimal places, not 2, not 1, 3 decimal places. Now, A of 1 is equal to negative 0.819. So since they are opposite, you say A of 1 and V of 1 have opposite sign. Therefore, slowing down. Does everybody make sense here?
Yeah.
Did I get it wrong? Did anybody get it wrong? But you are competing the A of t, which is y1 and y2. You compete with that, so they are opposite sign. If they are opposite sign, they are slowing things down. If they have the same sign, they're both negative or they're both positive, they'll be speeding up. Maybe. For the t equal to 2, will be speeding up. Is that okay? So that's a very easy part of AP exam. Now, finding average velocity. The problem is, most of you guys don't remember average velocity. There was a 2 definition of average velocity. The first one is S of B minus S of A over B minus A, but we don't have a position function. So, or if you integrate V of t, right, and between 2 to 4, and then multiply by 1/2 in the front, that is also going to be average velocity. Why? Because you think about if you integrate V of t, it's going to give you S of B minus S of A. Does that make sense? Then it will be S of B minus S A over 4 minus 2. So that's equal to 2. Does that make sense?
Yeah.
So that's going to be average value. You guys remember? Average value. Average value is different than average rate of change. Average value is the integral. You take an integral of this. So I'm going to choose this one over this one because this one is better. So then I can say, oh, okay, let's just go into second mode, math 9 integration between 2 to 4. And that's going to be vars, y bar function y1, I think. dt dx, and I press enter divided by 2. Is that okay? Is that what you guys got?
Yeah.
Is equal to 20.163. Again, 3 decimal places. Yes, Julissa? Huh? Okay, so if you go into here, right? And you're gonna go second quit. So you're gonna get to that. It's second mode. Oh, I'm so sorry. No, this is the average. No, this. Oh yeah, this is this moving up. Sorry, I look at the right thing. I put on the wrong thing. Sorry. No. You are just integrate V of t. If you integrate V of t, it's gonna get S of t. So what's average acceleration? As your average of acceleration is gonna be V of, it's the changing of velocity over changing of time. So it'll be V of 4 minus V of 2 over 4 minus 2. So in this case, I'm gonna do it outside. So V is var, this one is this part, function y1 of 4, is that what you're talking about here, Julissa? Minus math 9, math var function y1 of 4, 2, and I'm gonna close parenthesis here. I'm gonna go back to insert this parenthesis here. I'll divide it by 4 minus 2.
Is there another formula to add acceleration, or is it only for velocity?
That the average acceleration is a changing of v over changing of t.
Okay. It's not like, there's another formula for velocity. Is there another formula?
Yeah, but you gotta have acceleration formula. So if you have acceleration formula, it will be average value of acceleration formula.
You got a drip on today?
Oh, no, what drip? Thank you. No idea what drip you mean, but okay. When I am not looking fresh. I don't know, I'm just saying. I'm just kidding.
How come you need 2 parentheses over there right next to the 2? Because I got a different answer and I forgot to put that one.
Because you need to have order operation. You need to have the numerator subtracting each other and then divided by denominator subtract each other.
y1 of 2 divided by 4 minus 2, and then y1 of 4 minus 4.
Okay, total displacement. How do you get total displacement? Well, this total displacement is going to be between 1 to 5 v of t, right? dt. And it looks like very, very close to this one. So I'm gonna be lazy. I'm gonna go in. I'm gonna say, hey, I'm gonna be lazy. I don't want to type this again. I just type this, right? So I didn't type it that. I just go up to that, and I'm just gonna be between 1 to 5. Is that okay? How do I do that? I'm gonna show you again. So remember, I only need 1 to 5 at this case. So I just go up to here because this one is already 2 to 4, right? I go up here and I press enter. They will type that for me.
That's a cheat code.
Yeah, I just saved some time. I don't want it to type it again. Every time I type new things, I'm more likely to mess up. This is already typed out pretty much. I just between 2 to 4. So between 1 to 5, it's a 51. Somebody double check my math though. 987 negative. And that's all you're supposed to write. You cannot just write down negative 51.987. You have to write down integration between 1 to 5 v of t dt equal to negative 51.987. Does that make sense? Okay, total distance. What's the difference between total distance? Absolute value, right? So this one, I'm going to do absolute value here. I don't know if I can do it here. Let me try it. Second, catalog, absolute value, and var, y var function of y1, I think. And then it's between where to where? 0 to 3, right? Total distance between 0 to 3, right? So that's 0, and that's 3. And hopefully that's right. Is that right? Integration between 0 to 3. Absolute value of v of t dt. This is what you're supposed to write down. And that's going to be 12.836. Again, 3 decimal places to win. Am I going too fast? Okay, let's find the speed of speed equal to 35. There was 2 ways to do it. I'll show you 2 ways to do it, okay? For me, I will do it the first way, but I will even do a better way here. So I'm going to go to y equal to, and I'm going to graph another function 35. And because I want it when they equal to 35, so I just look for the intersection. But there's actually a better way to do it in a second. So I graph it right now. Wait, I don't have 35. So I can do click the window setting, right? And I'm going to do max at 50. Because it will pass 35. Do you see that? See those 2 intersections? You can do second calc the intersecting, and you can go into the right. I'm gonna do this first curve, enter, and second curve, press enter, and the guess 4.96. So that means v of t is equal to 35. T is equal to 4.96. Is that okay? Or t is equal to what? What's the other one? Second calc. Yep. And I'm gonna try to intersect here. I'm gonna go find it, but I'm not gonna worry about that value. So wait. Did I pass it? I cannot pass it. So do you see it's really hard to track those points? And because you don't know when it's what. So I'm going to show you the second way to find the second intersection. What I'm going to do is I'm going to go in graph. I'm going to say, hey, var function y1. And I'm going to say minus 35. Why minus 35? Because I can look for the zeros rather looking for the x-intercepts. So I look for the zeros. I think it's better. So I look for zeros. For this particular 0, I'm going to do, it's probably still kind of difficult, but because it's hard to find this, second calc zeros. Oh, I didn't do absolute value. You're right. I didn't forget. I forgot the absolute value. So it's absolute value v of t. I did forget that. So let's go back, change that. So absolute value. So that way you got 1 extra things, right? So second catalog absolute value of function y1 minus 35. And I'm not going to graph any other functions. I'm not going to graph any other function. I'm going to go to here. This is how you do it on the graphing calculator. So there are 2 x-intercepts. Let's zoom in a little bit. Let's zoom in a little bit. And I'm going to zoom in on this particular part right here. I'm going to zoom in here. Is that okay? And second calc, the zeros. So hopefully this one. So there's another one. Thanks for Nathan. 3.76. And 0. And I'm going to go find out the second calc. The zeros. TI Inspire, it can actually solve for you. but that's okay. 4.076. And I'm gonna do second calc all the way to the other side. The zeros, I'm gonna do from here, press enter, and press enter here. So 4.96. So those will be three values. 1, 2, 3. And, mhm. Speed is absolute value v of t. Because speed is only positive. So you only take account of positive velocity. Where it's equal to 35. So if it ain't equal to 35, that means you look for intersection. Or you can subtract 35 to the other side. So that's just say v of t, absolute value equal to 35, right? Or you can say absolute value of dt minus 35. I can just graph this function equal to 0. So I'm looking for the x-intercept when v of t minus 35 is equal to 0. Yes.
Why is the x-axis like when it equals 0? Like how's that like 35? Like how's that kind of
Subtract the 35 from the y.
from the beginning?
Yeah. He said the absolute value of v, so you can either solve for where it's equal 35 by making a line and then doing intersection, or you can just do absolute value minus 35 and then make it the zeros. Then put count the zeros.
There's 35 high, 35.
For absolute value minus 35, wouldn't that be like a line or something?
What? Absolute value 35. What?
Like with y negative 35.
No. Y-intercept is at those 3 points. Because when they equal to 35, I basically shift the whole graph down and just look for an intersection. Because instead of looking for intersection at 35, you basically move down the whole graph and look for the zeros rather than look at 35. And that's easier to look at. Okay, so that last part is I'm going to go back to the y function graph. I'm going to graph this one. I'm not going to go worry about this one, right? So I am going to graph this. And I'm going to zoom standard here. So hopefully they will show me the whole graph. But they say when the particle is slowing down. We talk about particles slowing down between 0 to 5. Now, between particles slowing down, that means acceleration is positive and velocity is negative. So only from this point here to this point. Do you see that?
Yep. Mm-hmm.
But this point is good. But then you have to look for the minimum. So I don't know where the minimum is. So I'm going to zoom. I am going to click on the window. I'm going to say it's negative 50. So if I have negative 50, hopefully I will see the whole graph. So now I see this. So this part going up, this is speeding up. This part is slowing down, right? So I basically look for the maximum and the zeros. Is that okay?
Yeah.
So I'm going to go to second calc. The maximum between this point, this is probably the hardest part. Now, no AP exam ever asked this part, but I asked just because I think I want to see if you really know the stuff. So it'll be, I would say 0.7852, and I only care about the x value because of the time. And I'm going to go all the way to zeros rather than the minimums. So I'm going to go 0 because you have a negative slope here. Press enter, and I'm going to press enter here. So that's equal to 1.57. Is that okay?
So yeah.
Union?
For one of them, I graphed the integral. I graphed the derivative, and I found the zero of that, and I got the same one.
Yeah, I didn't want to graph another. I didn't want to go to another function. So now for this region is a negative acceleration, but sorry, not negative acceleration. It's a negative and negative, right? Is that speeding up?
Yes.
Yeah, you don't want to speeding up. You want to here to here. So you want to go to second calc, the minimum here, and I'm gonna go to the minimum. But just press enter here, because that way I can actually understand two things. So 3.9327 And what's the next point here going to be? Second calc 0. Oops, that's too fast, right?
Okay, that's right. You did 0. Like
Yeah.
0 is defined as 0.
Second calculator.
4.71. And that should be good, right? That's what I got. Now you realize I did not use the initial condition at all. Not total displacement, not total distance, not speeding up, slowing down, not anywhere. But why do we need it used for the next part? Because we talk about this is going to be talk about a final position. So between 0 to 5, now this is the way you have to kind of play the game. You got 3 zeros. So the candidate of this, I'm going to do those two questions at once. So t equal to, well, we know at, where's the first x-intercept? 0.785, 0.785, right? And t is equal to what? What's the second x-intercept? 3.921, right? And there's t equal to 0, and t is equal to what? 5, I think. So what I'm going to do is I'm going to do a table. I'm going to do t. I'm going to talk about the displacement. Actually, the final positions. Final positions. Why does final position matter? Because at 0, I'm going to be at -2. Does that make sense? When t equal to 0, I'm going to get -2. Because the original question says when 0 at -2. Is that okay?
Yeah.
Now I'm going to go see, huh? Those are the x-intercept. Those are the critical values. And also endpoint, you should be worried about endpoints as well. So 5 is going to be -2 plus the integration between 0 to 5 of v of t dt. And at 0.785, 3.921, so it'll be -2 plus integration between 0 to 0.785 v of t dt, or -2 plus between 0 to 3.921.
So you lost it.
I will do it. I will show you in a second. V of t. So I'm going to do furthest left and furthest right all together. Okay, so I'm going to show you here. So I'm going to do second calc, and I'm going to go 7. Why? I'm just going to show you the area. So lower limit between 0 to 0.785. So that is going to give you 1.05, but it's going to be subtract the 2. So it'll be what? Negative 0.95, right? Is that okay?
Yeah.
Now that's that small area. Wait, 785? No, it's not 785. It's what? 1.57? No, where's the first x-intercept? Hold on a second. Let me calc where the zeros is. Hold on. Let me make sure this is the correct. 1.57. Oh, it's supposed to be 1.97. So it'll be 1.57. This is the 1.571. That's the first x-intercept. So I'm gonna do second calc 7 between 0 to 1.571. Is that okay?
Yep.
And then plus 1.905, so it'll be, wasn't -2, 0.095. Is that okay? Because that is a little bit to the left, but not furthest left. The first left right now is -2. Now I'm going to go to second calc that you're gonna do 7, and it's gonna do 0 to what? What's the next x-intercept? 3.96, 3.921. Hopefully that's right value. Oops.
Right.
Yeah.
Is it 92?
It's 4.712.
It's 4 point what?
4.712.
4.712, my bad. I picked the wrong value. 4 point what?
712.
712? Okay, let's do that. Second calc. I didn't mean to confuse you, but I'm looking for the zeros there. Second calc 7 and 0 to what? 4.712. Yep, that's right. So that's gonna give you what? Negative 58.156. So 4.712. Is that okay?
Yeah.
So is which one's furthest left?
4.712.
Probably, but we don't know yet until we go to 5. Second calc between 7, 0 to 5.
We know it's not 5, right?
So it's equal to negative 52.608. Now this one is what? The furthest left is right here. So furthest left. Where's the furthest right?
1.5.
Yeah. So this is kind of this one. The furthest right is this one. Furthest left is this one. Is that okay?
Like, which one's furthest left?
Furthest left is negative 58.156.
Are you getting -2?
It's true.
Yeah, you have to worry about -2 because you start with the position different.
Did you change the 7.5 to 1.5?
Yeah. I did. I changed it. It was wrong value.
I just put down like my x value. Without having one, I put my value too.
If they say justify the result, you have to show the table. If they ever say justify result, you have to show the table.
The experiment, right?
Okay, so for this particular question, between 0 to 12, v of t, when's the particle traveling left? What are you supposed to do? That means v of t is what? Less than 0. Is that okay? So it'll be cosine of pi 6 t less than 0. So when is cosine of pi over 6 t is equal to 0? When does cosine equal to 0? At,
Pi over 2.
okay, so pi over 6t is equal to what? Half pi, right?
Yeah.
So pi and pi cancel, so t is equal to what? 3?
Back 3 and 9.
And pi over 6t equal to 3 over 2 pi. So t is equal to 9.
Yeah.
And you have to do a number line. Between 0 to 3 to 9 to 12. Okay, so let's just say if I plug in 1. If cosine of pi over 6 is what? It's positive, right?
Yeah.
How about cosine of, I don't know, let's plug in 7.
Negative.
It's going to give you a negative, and this is a positive. So between 3 to 7? 3 to 9? Right. Do not evaluate total distance. Well, that's easy. Between 0 to 6, absolute value of cosine of pi over 6t dt.
Let me see.
Mhm.
How do you know that v of t is less than 0?
Just when it's
You plug in like 5. Cosine of 5 pi over 6 is what? Is it negative or positive? I don't even need to know. Yeah. I already finished 2 part already. I'm already like, yeah.
So B, that's the only answer. You have to like calculate.
No, you don't have to calculate because they say write, do not evaluate. They say write, do not evaluate. You are integration between 0 to 6 cosine of pi over 6t dt. That's it. Absolute value.
Are some parts worth more than the other?
I don't know. I'm just telling you how to do it.
Yeah.
C. Okay, let's look at a C. C is speed. So speed is compared to B of 4. What is B of 4? Cosine of 4 pi over 6. What's cosine of 4 pi over 6? It's a negative or positive. So it's less than 0, right? Now, acceleration. So I need to figure out what the acceleration of t is equal to derivative of cosine of pi over 6t. So what's derivative of cosine of pi over 6? Negative sine of pi over 6t, right? Times pi over 6. Is that okay? Chain rule. Is that okay? So what's the negative sine of 4 pi over 6 times pi over 6? What is sine of 4 pi over 6? Negative root 3 over 2, right? No, actually positive, I like. No. So this is negative here, right? Because negative sign, derivative of that. Times pi over 6. So is that negative or positive? It's negative, right? So it'll be negative square root 3 pi over 12. So since negative, and they're both negative, so it's speeding up.
What will it be? Is that gonna? Is it increasing, decreasing, or meter? Is it like a line?
So it'll be speed up.
And what are the numbers that you saw?
Huh?
What are the numbers that you
Negative square root 3 pi over 12. Because I take a derivative, right? And this is a of t. So a of 4, that means I'm going to plug in 4 for t. Is that okay? Okay, find the position of particle t equal to 4. So what are you supposed to do? You're supposed including negative 2. Why you need including negative 2? Because you're talking about final positions. Plus the integration between what? 0 to 4 v of t dt. Do you guys know how to take integral of that? Cosine of pi over 6t, right?
Yes.
Now, between 0 to 4. Now, we got to do u substitution. What is u substitution? Pi over 6t. Did you guys do u substitution?
No.
You have to.
You can just look at it.
He's gonna put a question to me, just look at it. I'm like, you can't. You have to do something.
That's why I say he's a shitty tutor.
In his head.
He's gonna be like telling somebody, like tutoring somebody, SAT is just like, and you charge somebody like $50, and then they were gonna ask you a question. You'll be like, yeah, just look at it. Duh. I'm like, how am I gonna pay you more than $20 if you just told him to look at it?
So I want you to explain it like the basic way.
Yeah, but you're trying to explain to Omar, and Omar.
I'm not like that. You gotta explain, buddy. Like.
Yeah, so it doesn't work like that.
I told Omar you can use them. I told him you can use
du equal to pi over 6 dt, right? So therefore, it's gonna be between. Now I'm gonna plug in the 4, and I'm gonna plug in the boundaries. So 4 is gonna be 2 pi over 3, right? So 2 pi over 3, and 0. Is that okay? Is that okay?
Yeah.
Then that's gonna be cosine of u du. Now what's integration to cosine of u? It's gonna be what? Sine of u, right? Sine of the 2 pi sine of, I'm gonna write down every step. Sine of u between 2 pi over 3 to 0, negative 2 plus like this. -2 plus sine of 2 pi over 3 minus sine of 0, which sine of 0 is 0. It's nice. -2 plus what? Cosine of 2 pi over 3 is what? Square root of 3 over 2?
See, how come we didn't do sine u squared over 2? The integral of cosine u, you did sine, but what about the u? Don't we do like u to the power of 2?
No, you're an idiot.
Okay.
No, because you integration cosine of u is sine of u. It has nothing to do it's not two different identical. U is the argument of sine. So you don't take integration of u. That would be bad. That would be bad math right there. Because what's derivative of sine of u? Derivative of sine of u is cosine of u. No, derivative of sine of u is going to be positive cosine of u.
That's you got it's negative.
Yeah, it's gonna be-
So imagine if you take a derivative of sine, am I going to get cosine? Why would it be negative sine? If I take a derivative of negative sine, what am I going to get? Negative cosine. If I take a derivative of sine, I'm going to go back to cosine, which is perfect. So -2 plus square root of 3 over 2, that's my final positions. Is that okay?
Mr.
Hmm?
Why do you put -2? It was in the initial.
Yeah, that's the initial condition. You start over there, you adding the distance. So final position matter with initial conditions.
I saw that the position one was like that graph. Every time it makes sense. F of 0 is visible.
It is, or you gotta integrate it, and you have to plug in the initial conditions, which is I don't want to do that. I will just do integration and its initial value in there. I think it's faster. Is that okay for everybody?
Yeah.
Are you lost? Okay, so I'm gonna talk about FTC last because I might run out of time.
Wait, no.
Yeah, that was the hardest question.
Not that one.
This one?
I want to see that. Yeah.
Yeah.
Like the reviews review. No, this is video.
But I'm worried about the net rate. Can I go over this one and this one? Oh, this one and this one. So let me go over the net rate first. Net rate is something that I will be. We did this one on the video.
Yeah, do that one.
All right, fine. Okay. So I'm gonna annotate this. I never annotate my life, but I'm gonna try to do that. This is the rate in, right? And this is the rate out. Is that okay? And there is an initial condition. So initial condition is this. So pretty much every time you're gonna get three situations. You got something's coming in, something's coming out, and you're like, oh, okay, well, how many cubic feet rainwater flow into the pipe during the first 8 hours? So what does that mean? What do you want? Integration, right? Because think about this. I said that on video too. I think about S of t is equal to meter. V of t is equal to meter per second. And A of t is equal to meter per second squared. Does that make sense?
Yeah.
And so usually they give you a rate. Rate is equivalent to speed of something. So think about rate as a velocity. So first of all, understand the units. Now they say how many cubic feet. That means I have the integration of rate. Does that make sense? Because if I integration of rate, I'm going back to meter. Or in this case, the units, feet, something. Is that okay? So integration between 0 to 8 of what? R of t, right? dt. I have no idea what is that. I'm going to trust your math. Can somebody tell me what's the right number here? 3 decimal places. Fine, I'll do it. Y'all,
I think stairs is not to be calculated.
20
Makes sense.
sine of x squared divided by 25.
Nah, but you gotta-
So I am gonna go to integration between 0 to 8, right? So I'm gonna go back, change to 0 to 8. I'm lazy. I just don't want to type that. 0 to 8. 76, is that okay? 76 0.570 cubic feet. Write down the unit there, and that's it. Okay. Is the amount of water in the pipe increasing or decreasing at t equal to 3? Now, obviously, this one we have to consider in and out, right? Yes.
We also consider the initial.
No.
No.
No, initial doesn't matter here. So how do you compare? So you think about amount of water. That means right here, right? Does that make sense? Amount of water is like amount of meter, right? Now, if you wanna to compare the increasing, decreasing amount of water, because amount of water is subject. Increasing, decreasing is a derivative. Is that okay?
Yeah.
So I'm going to go back to the rate. Basically, they just want it to be R of 3 minus D of 3. And look at, are they positive or negative? Is that okay? So I'm going to go back to D of 3. So I am going to go to D of 3. So I am going to say that's negative 0.04 x to the third. Minus a plus, sorry, plus 0.4 x squared, and then what? 0.96 plus 0.96, 96 what? X. So I'm gonna do y1 of 3 minus bar y function y, I think it's y3, right?
Yeah.
Hold on, it's y3. Y3 of bar y function y3 of 3, and that's gonna give you negative, it's less than 0, so it's decreasing. Is that okay?
Yeah.
I don't need to worry about initial condition because I'm looking at that specific time. Are they increasing or decreasing? Initial condition has nothing to do with it.
What is the difference?
Huh?
Difference?
It's yeah, the difference if y3 is bigger than negative y1 is bigger than
Now the C, you have to do the table because they say when the pipe is, and you have to integrate those. You gotta integrate the net in and net out. Hopefully I'll make a video clear enough to do that.
The test is till tomorrow, right?
Huh?
Is the test till tomorrow?
Yeah.
I don't believe in it.
Yeah.
Do you think we should worry about time, or is it something we should like?
You should worry about time. You gotta do it within time. Huh? Why? You pray to God and God answered. Pray the Lord, let the test be Thursday. Is that what's gonna be? And then maybe God answered. Yes, Julissa, the test will be on Thursday. Do homework?
No, I'm sorry, I didn't.
I already told you this is the most important
Yeah, I know.
homework.
I'm actually working
Mm-hmm.
on taking it. Video.
Drain pipe one?
But also like the F5 stuff like that.
I did look up some. Slowing down.
I got negative 20.163, negative 16,
Negative 16.
negative 12.84.
For this one, I just had 35. You go to eat, so put them up to into your calculator and started me off. I think that was the question. That's awesome, right? So yeah, I just set the original equation to, yeah. But, yeah, you just solved it.
For G, I got negative 0.786 to 1.5.
I had everything except the first number. The first number I got 0.785.
Wait, I just.
Did you H?
Oh, oh yeah, H was the easy one. I skipped it. You just find integral and you see when your value is the most bottom.
Yeah, but you have to take the two. You're the six.
Yeah,
The integral or the absolute value. Yeah, because it's total distance traveled, not total distance.
Ooh, interesting. Okay. So the absolute value of cosine of opposite 16.
I just put V and P, and that also works. DC.
All right. Come look at your homework. See how you're doing. Go. And you're gonna text her again. Huh? I already told you this is 20% your grade. I don't give a shit. It's like you piss me off.
I was confused that
Yeah, I don't know how to do it.
for C, I got neither, right?
Final and initial.
Which one?
C, when it's speeding up and slowing down, neither.
I got speed.
When you plug it more into both of those, then you get both are negative.
Yeah, both are negative. That means speeding up.
Really?
Yeah, because you have a negative velocity and you have a negative acceleration. That means you're adding more to your negative velocity. So you're speeding up in the negative direction. Makes sense? If the signs are the same, it's speeding up. If the signs are different, slowing down. Does that make sense? Because if I had a velocity of 5 and acceleration of 30, that means I just keep adding 3 on, right? So I mean, I'm speeding up. But if I have a velocity of negative 5 and have an acceleration of negative 3, I just keep speeding up right in the other direction.
So what would it be neither?
It's neither. I don't think I've ever. Well, maybe it's like. Wouldn't it both 0? I guess I don't know.
So,
I'm not speeding up.
So, yeah, I already have some. Yeah, I got 1.651.
I had 0.35. Wait, I might. This one I was a bit. Find the position of the particle. Did you do the initial condition? Remember there's an initial condition at t equals 0, x equals -2. So what was your answer again? Yeah, you need to do the integral and then minus 2. That's the initial condition. Because you integrated the equation, right?
Integrated it.
Yeah, but you need to when you're writing the integral, you need to write out the integral and then minus 2. Because that's the initial condition. See right there? The particle position as x equals -2 and time t equals 0. That means that you just have to add or subtract whatever the initial condition is.
I'm gonna go 0.346.
Yeah, that's what I get. Yes,
You can mark.
I don't think
We'll do it again. I do it again.
No, I saw it.
Okay, but then what was next? Okay. A, I got 3. Okay, this was kind of confusing because.
Yes.
All right.
But I forgot that it was like.
I did a video about TI-84's this part. So at least I'll give you an answer for the first part. Okay, so Josh and Young, you guys need to grab a chair, go work it outside. Because I'm gonna go over it. You guys can work together using calculator or whatever. But you guys can always watch a video later. So you and okay, so like guys, grab a chair too. You need 2 chairs. Okay. God damn, I hate Koreans. Except Chauvin. Chauvin's cool Korean. He's a good one. Wait, I'm live streaming. Oh well.
Said worse.
Korean never do homework except Chauvin. Chauvin's good. Ruben, you're my favorite Korean.
Dude, that should mean a lot to you, man. That's a great honor.
All right, so the first part I got. So you gotta write down 3 decimal places. Did you write down 3 decimal places? Yeah. Okay, so 3 decimal places. You should write down V of 1 is equal to 1.469. A of 1 is negative 0.819. And then initial condition A of 1, V of 1 have the opposite sign, therefore they are slowing down. Now, average velocity, there is 2 types. There is S of B minus S of A over B minus A, but position function never giving. So can I just take integration V of t? And I got integration V of t. So if integration V of t is going to be S of t, it'll be S of 4 minus S of 2 over 1/2. The same thing is integration of 1/2 between 2 to 4 V of t dt. So that's equal to negative 20.163. Anybody make questions so far? No?
Wait, how did you get the 1/2 on the integration?
1/2 is you have to divide it by the b minus a. So it's like average value.
Oh, you basically take the divided by 2 and move it
Put
out.
in the front. You had to put it in the front. You cannot put it inside because you put it inside that doesn't count because you gotta take it in. Wait, the 1/2 inside. Oh, actually, it doesn't matter.
I don't think it does.
It doesn't matter. Okay, but it's probably better to write outside. Yes.
So for average velocity, do you need for the S of t? Do you need to account for the initial condition?
No, you don't. Okay, so let's talk about when you should include an initial condition. Pretty much nothing, unless you're talking about final positions or the furthest left or right. Because furthest left or right is talking about final positions. Does that make sense? Because you're talking about the final. Any question about this part? So finding the total displacement is the absolute value of v of t dt. So it's negative 51.987. Oh, did I get average? Wait, hold on a second. Did I get average acceleration number? Hold on, let me go back and check. Let's go back up there. Negative 16.306, right?
Yeah.
So this one is a negative 16.306. Now you cannot, like I say on the AP exam, you cannot just write down the number. You have to write down the v of 4 minus v of 3 over 4 minus 3. You have to write it down in order to get credit because that's the most important part they want to see. And then the calculator answer, that's the second part they want to see. You need to have both in order to get credit. Yes.
What if the calculator makes sometimes round to 3? Like it just gives you a whole.
Then you round to 3.
How are you supposed to?
Just round to 3 decimal places.
Okay. No, like.
Oh, he round. They finish at second
Yeah,
place. That's why they finish 2 decimal place instead of
Yeah,
3
they-
decimal place. There's a way to change the float. I don't know how to do it.
It's in documents.
That's why I don't know how to use. Sean, can you help her out?
You'll also, whenever you do it,
I'm not really sure. I just use it in my. I don't even use the calculator.
Oh, low three.
I will change float 6 just because I can give you 6 decimal place. I can round it.
So, just when you like, when you're defining adding number 5,
between 4 and 5. Yeah. But like, where?
try to look for something.
How do you have it divided?
Average velocity is
I said my thing.
S of like b minus S of a.
Apparently, there are like 2 positions. You plug in.
All right, so shh. Raise your hand if you have questions so far for C, part A, B, C. Isabel, do you have questions? No? Everybody's okay? I'm gonna go to part D. D is a total displacement. That means without absolute value between 1 to 5 v of t dt. I got negative 51.9867. Total distance with absolute value, but the time also changed between 0 to 3, so it'll be v of t equal to 12.836. Got it? Now f is somewhat interesting. I'm going to show you two different ways to do it. I like this way. I like v of t minus 35. I just graphed that. I'm going to show you how to do that. So for example, this is the rainwater question. So I'm going to do the this question, which is e to the x times cosine of x. Okay, so then I'm going to do that. And I am gonna do, I'm gonna do this later. This the acceleration. I don't need acceleration anymore, pretty much. I am gonna graph 35. So either way to graph like this, and to change to 35, so you have to say y max is equal to 50 because you want to see 35. And you want to see this intersection right here. But the problem is this is not speed. What is speed? Speed is what? Absolute value of y1, right? So I'm going to say, I'm going to go back. I'm going to say, well, I'm going to go back to absolute value y1. So I'm going to second absolute value of y1. Is that okay? And then now you should be able to see that intersection. And whatever that intersection, there are 3. 1, 2, 3. Do you see that? Now, this is not a good way to do it. I'll show you an even better way. What's a better way is, now TI Inspire can have one way to do it. They can solve it right away. I think somebody did that yesterday. I think Rajesh kind of did it. Take a picture. I don't know if anybody saw that picture with TI Inspire. They can get all 3. I like the decimal way better because I like the intersection way better. But I like this way even better. So instead of graph y1 and 35 intersecting, I could have graphed this minus 35. Why minus 35? Because you look at here, right? I set v of t equal to 35. I can move the 35 to the other side, set it equal to 0. If I set it equal to 0, that's even better because I can actually graph this. I can look for the intersections right here. Second, calc 0. And I probably need to zoom in that a little bit more. So that's zoom standard. And I'm gonna zoom in a little bit more too. So now I want to see this intersection right here. So I'm going to go to between here. I want to see those intersections. Those intersections, second calc, the zeros. Now if you see here, 3, 4. Wait, where's my cursor? Do you see my cursor? I don't see my cursor. That's a problem. Where the hell's my cursor? 0. Somebody know how to find my cursor? First one is 3.76. I can't see my cursor, but you guys should be able to see that the cursor here. Wait, hold on a second. I am graphing. Oh, I don't want to graph this. Sorry. I should have. They go by order, so that's why. 0. Left bound. I see my cursor. Yay! Cursor is reappear. So press enter. Press enter. I should get 3.7605. Any question here?
Wait, how do you find this? How do you find the 4 points again on the graph?
What?
Like, I have the absolute value graph. It was like, how do you find the 0 points?
Absolute value minus 35 because you want to shift the graph down to the 0. Huh?
Have the graph with the value of
V of t minus 35.
yeah.
Then just zoom in. You can zoom in at those 3 intersections, and then you can see that zeros.
No.
Question?
And then you go to zero.
What question were you talking about?
Me? For second count. And then you set the boundary.
Right, 3, right?
So like, oh yeah, I want to check the last one. I know it's so you just go to
Okay, I got A for 3, and then 10 minus 2.
oh yeah, I didn't see it. Oh wait, there was 2 parts to
And
it.
2 parts to A.
There's one.
There's I think negative 6 and
1 to 5. Oh, for 5, it was just. Oh, you can just click. You can just click. Yeah.
Okay, and then I
It's
will
not
go.
too, you don't have to check. Wait, I had a question for. So I did G.
It's just
But like, low-key, like when my friend was explaining to me, it kind of didn't make any sense there. What AG? I mean, what 1G?
Find the interval where the particle's slowing down.
So I know you graphed with your velocity and your position graph, and when your velocity is negative and your position is still positive.
Any questions so far?
What he said, you just find the zeros in 2 graphs.
Yeah, that's like the. Yes.
And once you graph it, I want from this minimum